This video is going to cover worksheet 6A, 6B, worksheet 7, and then worksheet that is arc, central angles, and chords. These are some extra practice in the geometry yellow book that we have. We won't necessarily assign problems, but they're good problems, good practice problems that we need to get ready for the test. We have a good assortment, kind of covers all of the areas, and really gets us some extra practice. So let's start working through these. So we start with our first one. It's using the inscribed angle idea because I have that 31 goes to the arc out here. Now if I have an inscribed angle, I double that to get the arc, which should be 62. And then I could add 204 and 62 to give me this total. And that gives me 266. I'm then going to subtract that from 360. Looks like 94. And that is my answer for x. That is what's left. No, not 92. 94. That is what I have left for x. Okay, now we go to number 2. If we look at this, we have a tangent and a chord. One way we could look at this problem is say, well, 84 is going to have a supplement, and that is 96, which once we have that angle, we can double to get that x is 192. Now maybe you don't see it that way. Maybe we can go a different way to get to it. I could have taken also 84 and doubled that and gotten 168 and then subtracted that from 360 and gotten 192. So in that case you have the supplementary angles and you have the two arcs that add to 360. You can in either way get to your other angle. Now number 3, I have an angle inside the circle. So to get that angle, notice it's not on the center, I'm going to take the average of the arcs. So I'm going to say x equals 164 plus 72 over 2. If I add those, it looks like I get 236 over 2. We take half of that, I think that is 118 would be our angle for x. Okay, we go to number 4. Same idea as the one we just did, but we don't directly get the angle that we want. We actually want the angle next to that 90 degrees, which, well, since it is 90, is also 90 degrees. But if we look here, we're going to say 90, the angle, equals 3x plus 9 plus 2x plus 7 divided by 2, because it's the average of the arcs. 90, well, instead of 90, let's just multiply over by 2. So we get 180 equals 5x plus 16. If we subtract 16 there, we get 164 equals 5x. So x is 164 over 5. Now 164 over 5, that is going to be a decimal. It's not a whole number. So let's see what we get. We get it's about, or it is 32.8. But if you just wrote 164 over 5, you'd be perfectly fine. Okay, now we go to number 5. We have a arc, 294. So why don't we figure out what this arc left would be from 294. And if you subtracted that from 360, you'd get 66. So now we have the angle that matches up to it, but we have to be careful. Is that a central angle or an inscribed? This angle is on the center, so it actually is the same, so x equals 66. If it was an inscribed angle, looked something like that, so it hit on the circle, it would actually be half of the 66. But in this case, we're good. We have the value that we need. Now we go to number 6. So they line up here. If I look, I have 59 and 65. I want to find those average of those arcs. But we have to be careful because the average of those arcs is not x. Let's just call it y. That's actually the angle next to x. So I could say y equals 59 plus 65 over 2. We get 124 over 2, which comes out to be 62. Now if that's y, we want the angle next to it, x. So what we would do is do 180 minus 62, and we get 118 equals x, because it is the supplement of angle y. Okay, now moving down to number 7. So 236 is the big arc. I need to find the other arc. So I'm going to take 360 and subtract 236, and I get 124. Now, this is where I have an angle on the outside of the circle. When I have an angle on the outside, I want to find the difference. Zoom in a little bit. I want to find the difference of the two angles, two arcs, and then divide by 2. So inside I add. When it's outside I subtract. So it's going to be x equals 236 minus 124 over 2. If we subtract here, 236 minus 124 is 112. And we get, nope, not over 6. Let's try that again. How about over 2? And we get that our answer is 56. So that is 56 for angle x. Number 8 is going to follow the same idea, but we're not going to directly get to x. What we first have to do is find this inside arc, this little arc. Once we have that, we can take whatever value that is, add to 31 to figure out what we know, and then subtract it from 360 to figure out what we have left. So it's really two parts. We first need to get that arc, then we can find x. So to get that arc, let's just call it y, just because we need a name for it. We already got an x. We're going to say the angle equals big arc minus little arc divided by 2. We have to be careful that we don't write y minus 131. We want the big minus the little because we want the positive result. We know that arc has to be smaller. It has to be smaller than 131. So we have to make sure we do get that correct setup. We get 54 equals 131 minus y. If I subtract 131 from 54, I get negative 77 equals negative y, which is okay. So we just know y equals 77. And now I can add 77 and 31, and I get 208. And I'm going to subtract that from 360, and I get 142 for angle x. Let's try that again, 152 for angle x. Okay, let's go now to number 9. So here, we're going to use that angle on the outside again, but we first have to do a little bit of work to get to that point. Notice how these chords here are the same. Since they're the same, I know that that is also 103. So I can use 103, 103, and 65, add those all together, I get 271. Now why I did that is I want to find what's left in this arc, 89, now to set it up. So now I have the big arc minus the little arc, and I can say x equals 89 minus 65 over 2. Looks like 24 over 2, so x is 12. Okay, number 10, something a little bit different now. So this is an inscribed quadrilateral. When we have inscribed quadrilaterals, we know that they are supplementary. Now, why that works, we'll take a second to look. If I looked at 5x minus 4 here, that would go to this arc. It's an inscribed angle to that arc. 2x plus 51 would go to this arc. So together, those two arcs add to 360. They take up the whole circle. So then if we take that idea of inscribed angles and take half of 360, then what that tells us is that the two angles that we have to be half of 360, or 180. So anytime we have an inscribed quadrilateral, like we have here, the two angles that are opposite of each other will be supplementary. So 5x minus 4 plus 2x plus 51 equals 180. So we get 7x plus 47 equals 180. that becomes 7x equals 180 minus 47, 33. And if we divide 133 by 7, we get x is 19. Okay, number 11. First we need to find the arc out here. So once I have that, we'll call it y for now. Once I have that, I can go forward and find x. So to find y, that's going to be the angle equals, now big arc minus little arc. 40 is the little arc. I want that to be smaller than the big arc. So it's going to be y minus 40 over 2. If I multiply over the 2, I get 58 equals y minus 40. So y turns out to be 98. So let's just erase the y and call it 98. So now I have to figure out what I have left to make x. Well, what I have taken up so far is 80, 40, and 98. So I get 8. 12 and 9 is 21. I have 218. I subtract 218 from 360. And I'm left with 142 for x. Okay, we move on. Number 12. Now, let's take kind of a long approach to it, and then we can probably see the shortcut that we want to use in the future. So 11 is an inscribed angle. If it's an inscribed angle, I know that this arc is 22. Now, we also notice that we have a diameter cutting the circle in half. So that means actually the left half of this arc is 180. If that's the case, the other arc on that side is 158 because it's 180 minus 22. Then that 158 is the arc that goes to the inscribed angle of x, which would happen to be 79. So 79 is our answer. Now you might have noticed something here, that 11 and 79 is 90, which means that last angle in the triangle would have to be 90, which makes sense because this would be half a circle, so it's 180. So actually, anytime we have a triangle going through the center, a side going through the center, it's going to be a right triangle with the right angle is opposite that diameter. So really, if I had 11, I could have said, oh, well, 11 is one of the angles that adds to 90. I could have subtracted it and gotten to 79 that way, but that will always work. Okay, we get to 13. If I look at these two angles, 37 and x, they both go to the same arc. So the long way, I can double 37 and get 74, and then take half and get back to x. X, though, is 37. If inscribed angles go to the same arc, then they are the same, and that's enough. But again, we could have used that 74 as kind of a step in between the two. So now we're looking at more segments. So on 14, these are both secants. So when we have secants, we're going to do the product of the entire secant times the outside portion. So let's look at that 4 and x secant first. So the entire secant is 4 plus x. And then the outside portion is 4. Now, that's equal to the other secant, where the entire portion is 11, and then the outside portion isn't 5, but it's actually 6, because 6 and 5 gives us 11. So that's times 6. So this gives us 16 plus 4x equals 66. 4x equals 50. So x equals 50 over 4, which is 25 over 2, which we could say x is 12.5. Okay, 15 now is the same idea, but now we have a tangent. So we're going to let's first do the secant. So it's the entire secant, 22, times the outside portion, 10, is equal to, now in this case it's tangent squared, so we're going to write x squared. So I get 220 equals x squared, where x is the square root of 220. If you simplify the radical 220, you get the factors of 220 as 2, 2, 5, and 11. So that means I can take out a pair of 2's, and I have just the 5 and 11 left, which is just 55. So in simplified radical form, which is the appropriate form you should be writing it in, we get 2 root 55. For 16, these are chords on the inside. I'm going to do the product of each part of the chords. So x times x is x squared, and 3 times 27. So I multiply the parts of the same chord together. Well, this becomes x squared equals 81, and I can see that x is going to be 9, but it could also technically be negative 9, but negative 9 wouldn't work here because that would tell us that the length of the sides of the segments are negative 9. We can't have a negative, so we just go with the positive. Okay, 17, I have two tangents. So I'm not going to do tangent squared equals tangent squared. These are just tangents to a common point. We know those are the same. 3x plus 17 equals 6x minus 5. I can add over the 5, subtract the 3x, I get 22 equals 3x. So x is 22 over 3. Now for 18, this is just like what we did above. I have the entire secant, x plus 8, times the outside portion equals the entire secant times the outside portion. I get 8x plus 64 equals 170. 8x equals 106. So let's see what we get here. We get 106 over 8, which simplifies to be 53 over 4, which is 13.25 as a decimal. But 53 over 4 would be perfectly fine, acceptable answer. For 19, just like the one right above it, we're going to multiply the parts of the same chord. That's 8x equals 4 times 7. 8x equals 28. X equals 28 over 8, which becomes 14 over 4. We can keep going there. Just divide it by 4 to start. I get 7 over 2. So x is 3.5. Okay, 20. We have the entire secant, x plus 5, times 5 equals the tangent squared, which is 9 squared. 5x plus 25 equals 81. If I subtract 25 from 81, I get 56. So x is 56 over 5, which is 11.2. 21, something a little bit different here. So in 21, they tell me that AB is 48. But I actually have a radius kind of bisecting it here. So I'm going to make these actually both 24. It wants us to find the radius. I'm going to make that a radius, because if that's a radius, I can say that r squared equals 10 squared plus 24 squared, because again, that radius bisects the chord and gives us a right triangle. So r squared equals 100 plus 576, or r squared equals 676, and the square root of 676 is 26. So our radius here would be 26. Alright, so our next one has quite a bit here. So we're going to kind of just work through it. Maybe if you were to do it, you do it a little bit different order, but it could be a different approach to it. Let's just kind of start figuring out what we know and what we can find. So let's see, I got 124, 140, and 62. Those are all parts of the circle. It kind of leaves one part left, AD. So I could do 124 plus 140 plus 62, and that gives me 326. So if I subtracted that from 360, I now have that last piece is 34, which is right here. So let's see where to start. I want to probably start with maybe a central angle. Notice angle 8. That is a central angle that goes to arc DB. Spans that stretch. So that goes from D to B, so I can add 34 and 124 and I get 158. What else could we go with here? Well, look at angle 3. On angle 3, I have a tangent and a chord. So I know that 3 is going to be half of its arc, and its arc is 124, so that's going to be 62. But since that's 62, don't I also know that the measure of angle 9 is also 62 because they're marked as the same? You know what? No, that's not marked as the same. We need to fix that. Angle 9 is just referencing the size of it, and that's actually going from the radius. From the radius to the tangent would be 90 degrees. So there's a right angle there. Alright, so what else can we do here? Angle 5. If we look at angle 5 is an inscribed angle that goes to 124. Since it goes to 124, it's actually half, so it's 62. Let's go with angle 2. Angle 2, we have 34 and 140. The 140 is the big arc, and the 32 is the small arc. So this one's 140 minus 32 over 2. We get 108 over 2. So angle 2 is actually 54 degrees. Where should we go next? Let's kind of highlight these when we're done. We got 2 done, 3, 5, 9, and 8. Why don't we go angle 6 next? Now, the measure of angle 6, let's see, I have 124 is one of the arcs, and then it also goes to the 140 and the 62 together, which we have here's the small arc, here's the big arc. So to get angle 6, I'm going to do the big arc, 202, minus the small arc, 124, divided by 2. 202 minus 124 divided by 2 gives me 39 degrees, and that is angle 6. Let's see if I can erase things a little easier here. All right. Where are we going next here? We got 6. Let's circle that. Why don't we look at angle 4 next? Angle 4. Angle 4 is inside the circle, and it goes to 2 arcs. It goes to the 34 and the 140. So I can add those two together. 34 and 140 is 174. And then half of that is 87. So this is 87 at angle 4, which is next to angle 7. Angle 7 would be its supplement. So that would be 93. Which leaves us with maybe angle 1. We can go there. Angle 1. Oops, got to change color here. Angle 1 is an inscribed angle that goes to the 34 degrees. So I'm going to take half of that, so that should be 17. And then the last one we have, I believe, is angle 10. And if I look at angle 10, that is an inscribed angle that goes to the 62, so that should be 31 degrees. So quite a bit there, but looks like we got through all of the parts. Now, you might have done it in a different order, and that's perfectly fine, but it's just making sure we're getting to those same ways. There may be multiple ways to solve these circle problems, but the key thing is we are getting to that end result because we are following the rules that we have. So now we're looking at 6b. So kind of working it through sets of problems now. So first one we have, let's mark up what we know. We have BC is 50, CD is 70. It looks like we're looking at different angles. So CBD is our first one, which is right there. CBD is an inscribed angle. That inscribed angle goes to 70 degrees, so we're going to take half. We get 35. So now we go to angle ADC, which is here. ADC is an inscribed angle that goes to arc AC, if you don't see that. Well, we know AC is actually 180 degrees, so half of that would be 90. Okay, next we go to COD, maybe. My eraser is deciding not to work. I guess we're going to leave it there. All right. ADC we said was 90. Okay, COD. COD is a central angle. Central angle that goes to the arc of 70 degrees, so that one will be 70. DAB, the major arc that goes around here, DAB, that's going to be everything but the 50 and the 70. Looks like I'm not going to be able to erase. So everything but the 50 and the 70. So we take 50 and 70 is 120. We subtract, we have 240 left. We have ADB is our other arc. Well, looks like we got rid of it. So ADB is where we're at now. ADB is this arc of the circle. So we can take it two different ways. We know that top half ADC is a half a circle, so it's 180. So we could do 180 plus 50, which is 230. We could also say, well, why don't we just subtract away that piece? AB is 50 less than 180, so that means it's 130. So you could have done 360 minus 130, and we also would have gotten 230. Last one, BCD. We're looking for the angle. BCD, make sure we don't pick the arc. So that is a rather large angle. Now we're going to think of the arc that it takes up. Now the arc that it takes up is DAB. So the inscribed is half the arc, so it's half of 240, so it should be 120 degrees. So in our next set, we already have our given information marked, and I need to find some angles. If I look at angle 1 and 2, we could sit there and try to find the arcs, but notice we have that quadrilateral ETDC in there. That quadrilateral is going to make things a little bit easier because we know that in a quadrilateral, the opposite angles are supplementary. So the angle opposite angle 1 is 80, so that means angle 1 will be 100. The angle opposite angle 2 is 60, so we know that will be 120. Okay, now we can start working through finding some other things. So let's see, we need to find arc CE. So I know that the arc this arc here matches up to 80 degrees. So the total of this arc should be 160. It's Since I already have 110, that tells us that I have left 50 degrees there for CE. For CD, I could probably do the same thing. Let's check. CD, let's look at this arc, which again we know that one's 50 already. Since 60 is there, we know it should be a total of 120, so we get 70 for that arc. Now we go to angle 3. Let's keep what we've at least found, because it might help us make things a little bit easier. So we got 50 is that arc, 70 is that one. Well, angle 3 happens to be an angle that goes to arc CD. So that means it's half of 70, it's 35. And then we get to angle R. Now angle R is not half of 50 because it's not on the circle. It's not an inscribed angle. It's outside. For that one, it's actually going to be the big arc minus the little arc over 2. And to make it a little clearer, we'll draw angle R out so we can see that its big arc is the 70 plus the 130, so that's 200, minus the little arc's 50 divided by 2. So that gives us 150 over 2, or 75 degrees. Next set. So I need to find, let's start with JPM. So this angle here. Now if we look at that angle, we can take big arc minus little arc divided by 2. So to do that, we need to find that our big arc here is all of this. So that's 50, 180, or 50, 80, and 110, which is 240, which means our little arc should be 120. Now, just to make it a little bit easier, we'll have that 50 and 30, that's 80. That probably means that last piece is 40. We might need that later. Why not? We can have it now. So JPM is going to be the big arc, 240, minus the little arc, 120, over 2. Well, 240 minus 120 is 120. Divided by 2, we get 60. Now that probably should tell us, as we solve the rest of them, angle 1 and 2, they should be smaller than 60 because that total between that one angle 2, and the other angle next to it should be 60 degrees. So it's a good way to check as we go through. Alright, angle 1 is going to be big arc minus little arc divided by 2. Big arc is 80 minus little arc divided by 2. That's 50 over 2, or 25. Angle 2 is going to be the big arc, 110 minus 50 over 2. 60 over 2 is 30. And angle 3's last one. So on this one, angle 3 is an angle inside the circle. When it's inside, we take the average of the arcs. Its two arcs are 50 plus 80 over 2. That's 130 over 2, or 65 degrees. Let's adjust it here. Okay, PQ is tangent to circle O at Q. PQ is 15, PO is 17. We're going to have to draw that. So I have a circle. PQ is tangent at Q, so that says I have Q here, I have P, and it's circle O. So I'm thinking we got a right triangle. PQ is 15. PO is 17. We need to find the radius. So this is setting up to be a right triangle because we know the tangent and the radius are perpendicular. So to find our radius, we're going to do 17 squared equals 15 squared plus r squared. 17 squared is 289 equals 225 plus r squared. We get 49 equals r squared, so it looks like our radius is 7. On 18, find the total number of common tangents that can be drawn to two coplanar circles that are externally tangent. So it looks like two circles that have a common point. We could draw one at their shared point, one on top, one on bottom. Looks like we'd have three common tangents. Okay, next one, if a line is on a plane of a circle, try again. If a line in the plane of a circle is perpendicular to the radius at its outer endpoint. So if I have a circle and a radius and a line is perpendicular right there, then that would be our definition of a tangent. Okay, moving down here, we have angle 1 and angle 2 are congruent. Let's mark those. And angle 3 is 100. Now, let's just kind of think ahead. If angle 1 and 2 are congruent and angle 3 is 100, and I know they have to add up to 180, that kind of tells me already that 1 and 2 are each going to be 40. And I could even mark out here that they're 40 because they're all central angles, so the arcs are the same. Maybe that makes things a little bit easier, and you know the bottom half is also going to be 180. So let's see what it does for us. So RS has an arc of 40. RTU starts at R, goes through T, ends at U, that's 180. And SRU starts at S, goes through R, ends at U, that's 40, and 180 is 220. Last part we have to say what arc is congruent to RS. The arc that's going to have the same measure as RS, meaning it's congruent, is going to be arc TU. Okay, moving down, we have arc AEC is 300. So that whole thing starts at A, goes through E, ends at C is 300. Let's skip a little step. That's 300. That leaves 60 down here. But I have a perpendicular radius or perpendicular diameter to a chord. That's going to cut it in half, so let's actually make each of these arcs 30. We also know the radius is the same, so that's 8. So just thinking ahead, we actually already know that AB is 30. That's the first one. Angle APB, since it's a central angle, it's the same as the arc, is also 30. If we need to find AD, how could we do that? Well, let's see. We know those two are the same. We also know that, well, wait a minute, this central angle is 60 degrees. And since if I have an isosceles triangle in there, like this, where this is 60, and these are both 8, aren't all the angles 60 degrees, making it equilateral? So doesn't that mean that from A to D, if it's 8 all the way, each of these parts are 4? So we can make it 4. And that means the last part that we need is DB. Now we know the radius is 8. If DB, well, if P to B is 8, let's redraw it out here now. So we have 8, 8, and 8 here. This is 4, and this is 4. We need to find this portion. So it's really whatever the height is of that triangle minus 8, or subtracted from 8 to give us the leftovers. So let's see, in that triangle, we know it was equilateral, so if we cut it in half, doesn't it make it a 30, 60, 90? Now in a 30, 60, 90, at the shorter leg is opposite the 30, there's my 4. I double that, gives me my hypotenuse, okay, which means my other leg is 4 root 3. So we could actually say that dB is 8 minus 4 root 3. Now let's just check the decimal just to make sure it fits. 4 root 3 is about 6.9. So we could do 8 minus 4 root 3, and it's about 1.07. Say it's about 1.1. Okay, 28. I have that, let's zoom in a little bit. PQ is 16, OX is 6, OY is 7. We need to find RS. Now we know they're not the same because 6 and 7 don't match. They're not equidistant. But if I could find the radius, that would probably help me find RS. So we're going to find the radius on the triangle on the left. Now 16 is PQ, so half of that is 8. I can use Pythagorean theorem to find the radius. R squared equals 8 squared plus 6 squared. And by doing Pythagorean theorem, we actually get that R is 10. Because 8 squared is 64, 6 squared is 36. That's 100. The square root of 100 is 10. So this is 10, which would also be 10 over here. So either radius is 10. Now I can use that to solve for Ry. So I'm going to say 10 squared equals 7 squared plus Ry squared. 100 equals 49 plus Ry squared. We get 51 equals Ry squared, so Ry is the square root of 51. Now, we actually want twice that, so this is the square root of 51. This is the square root of 51. We double it, that's 2 root 51. Because we have 2 of them. If you wanted to find what that is approximately, well, it's about 14.3. Approximately 14.3. So that would be a suitable answer. Okay, 29. EF and GH are congruent. So that means these two arcs are the same, which actually means that HG and EF are the same. Well, that's a good thing. OX is 5, GH is 24. We need to find OG. So OG is that radius. So let's break this triangle out here. I have G, a point there, and O, and that's actually my right angle. So I'm looking for the radius. I know that from the center to the chord is 5, and 24 is GH. I'm going to take half of that. It's 12. So R squared equals 5 squared plus 12 squared. R squared equals 25 plus 144. We get R squared equals 169, so R is therefore 13. And OG is our radius, which means it is also 13. Okay, last one on this page here. Find the length of the chord that is 3 centimeters from the center of a circle with radius 9. So a chord that is 3 centimeters away, and the circle is radius 9. So we're looking for that value, which we could then double to find the chord. So 9 squared equals 3 squared plus x squared. We get 81 equals 9 plus x squared. X squared is then 72. So x equals the square root of 72. We should probably simplify that now because we're going to need it anyways. 72 simplifies, well, let's see, it's 2 times 36. And that's 6 times 6. So let's rewrite it as 6 root 2. So that's 6 root 2, and I have 2 of them. So the chord is 2 times 6 root 2. Therefore, it is 12 root 2. Now we're on worksheet 7. So we start with number 1. We're kind of back on our inscribed angles. So I know if I double the 26, I get 52. Now I need to find the arc that's next to it. You may have noticed we go through the center, so it really cuts the circle in half. So we want to do 180 minus 52, which gives us that x is 128 degrees. Number 2, I'm going to find what's left over from the 210 and the 82. 210 and 82 is 3, nope, it'd be 292. So we're left with 68 degrees there. We take half of that, so x is 34. For number 3, I have 82, and x is the inscribed angle. So since it's inscribed, we take half, and we get that x is 41. Number 4, if 280 is that arc, or the angle that goes with it is 140, which we can subtract from 180 and get that x is 40. We can double check that because if we double it, it's 80. 80 and 280 add to 360. For our next one, number 5, I know I have congruent chords, so the arcs are the same, so why don't I just call them both x? Because I know that 190 plus 20 plus x, or 2x, equals 360. So I get 210 plus 2x equals 360. 2x equals 150, so x is 75. Number 6, I'm going to double 64 and get 128. And then I can do 360 minus 128. And get 232. Now that 232 represents the rest of the circle, which are 2 equal parts. So I take half of 232 and I get 116 is x. For number 7, I'm going to solve first for this y because that lines up with the 40 and the 100. Because that y is going to be the average of the two, 40 plus 100 over 2. That's 140 over 2. So it's 70. Now if that's 70, that means x is its supplement, so x would in turn be 110. Number 8 is just like number 7, just in a little bit different order. We know that the angle 73 is equal to x plus 64 over 2. If I multiply by 2 to both sides, I get 146 equals x plus 64. I then subtract 64 from 146, and I get 82 degrees. In number 9, I have 300 degrees total already for the arcs. That leaves me with 60 right here. Now 60 is important because that's the arc that goes to the inscribed angle x, so I take half of that and it is 30 degrees. Because when I have an inscribed angle, I take half the arc. Number 10. In order to find the angle on the outside of the circle, I have to take the difference, big arc minus little arc, and divide it by 2. But I don't know the little arc yet. So I'm going to do 167 plus 68 plus 95. And if I add those three together, I get 330, which leaves me with 30 degrees right here, 330 from 360. So now I can say x equals 68 minus 30 over 2. X is 38 over 2, so our answer is 19. Number 11, in order to solve for x, again I need the little arc, but since I know that those two chords are congruent, I know this is also 100 degrees on top for the arc. If I add all those up, I have 290. I can subtract that from 360. I have 70 degrees left here. So x equals 90 minus 70 over 2. That's 20 over 2, so x would be 10. So for number 12, we now need to find the little arc, and that's going to lead us to find x on top, what we have left. So we're going to take 29 equals big arc 90 minus little arc. Let's call it y for now, just to give it a value. Divided by 2. Remember, it's the difference divided by 2. I get 58 equals 90 minus y. If I subtract 90 over, I get negative 32, so that means y is 32. And now I can take 90, 170, and 32, and I get 292. Up there, so that's everything, and then I subtract that from 360, and I have 68 left over, and that's x. Number 13, I'm going to find this arc out here, y. Once I have that, I can find x, which is the value not included. 35 equals big arc, y, minus 80, little arc, over 2. 70 equals y minus 80, so we get that y is 150. Now if that's 150, we combine it with the 80 and get 230, which is all of this, and that means we have 130 left over for x. Okay, now 14. I'm going to first find what the little arc is. So I'm going to take 360 and subtract 285 from it. And I get 75. So now that's x equals 285 minus 75 over 2. I get 210 over 2, so x is 105. For 15, it's now inside. So I'm going to take the two arcs, I'm going to add them and divide by 2. So I'm going to say 72 equals 5x plus 17 plus 5x minus 3 over 2. I'm going to multiply over the 2 and make it 144 equals 10x plus 14, which I subtract and get 130 equals 10x, so x is 13. For number 16, I'm going to multiply the parts that make up the same chord. So that would be x times x is x squared, 5 times 10, so I get x squared equals 50, x equals the square root of 50, which I can simplify because the square root of 50 is 25 times 2, and that gives me 5 comes out, 2 stays in, it is 5 root 2. On 17, it's going to be a tangent and a secant. So it's going to be the entire secant, which is 15 plus x times the outside part, x. That's equal to the tangent squared, 10 squared. So I get 15x plus x squared equals 100. And if I subtract it over, I actually get x squared plus 15x minus 100 equals 0. And this goes actually some algebra where we do have to factor. And what we can do here is say, well, I need the factors that multiply to be negative 100 that add to 15. So if I think of my factors of negative 100, I have maybe 25 and 4, 20 and 10, or 20 and 5, 10 and 10, different ones we want to look at there. And what we actually get is if x plus 20 and x minus 5 equals 0, those are the factors that work. Now, they're not both our solutions. We need to take the one that works. With x plus 20 equals 0, we get negative 20. We're not going to have a negative value. But if we look at x minus 5 equals 0, we get our solution is x equals 5. Now for 18, we're going to do the same idea, but now it's secant and a secant. So the total length of our top secant is 15 times the outside is 5. The total length for the bottom one is 22 plus x times the outside, which is x. I get 75 equals 22x plus x squared. We reorganize it. We get x squared plus 22x minus 75. My factors of negative 75 that add to 22. Well, I have 25 and negative 3. If I take x minus 3 and set it equal to 0, I get x equals 3, and that's going to be my solution for up there. The reason why I don't do x plus 25 equals 0 is that turns out to be x is negative 25, and we can't have a negative solution. For our last one here on this row, we get x squared, tangent squared, is equal to the total secant, which is 13, times the outside, which is 8, gives us x squared equals 13 times 8, which is 104. So x equals the square root of 104. Let's look at factors of 104 off in the corner here. 104 is 2 times 52, which is 2 times 26. Looks like we can write that one as 2 root 26. Now you might have noticed another way to do that one is to make Pythagorean theorem out of that. You could have then done 13 squared equals 5 squared plus x squared. Which actually changes our answer because we get 169 equals 25 plus x squared. So x would be 144, and therefore we get x is 12. Now, maybe you see the error I made. So what we actually wanted to do there was extend this. So we actually were wrong in this first one, and we get used to that patterns of problems, and it happens here. But what we want is this is incorrect. The actual total secant would be 5, 5, and 8, which is 18. And then the outside would still be 8. So it would be x squared equals 8 times 18, which is now 144. So we get x squared equals 144, which explains why we get 12. So it should be 12. So we got to pay attention there. Looks I'm just as bad there. We got to watch out when we do get those values. All right, down to 20. Our center, if we remember for a circle, it's x minus h squared plus y minus k squared equals r squared. So our center in this case is what we subtract from x, which is nothing, and what we subtract from y, which is 4. So 0, 4 is our center. Our radius is what we square to get 72, which is the square root of 72, which we found earlier is 6 root 2, which again is just the square root of 72. Now we're going to plug that back in and write the equation. So it's going to be x minus 5 squared plus y minus negative 1 squared, which is plus 1 squared, equals 7 root 2 squared. Now when we square 7 root 2, we square the 7. And when we square a square root, we get the number. So we have 49 times 2 is 98. So our equation is x minus 5 squared plus y plus 1 squared. Okay, now we're on to arcs, central angles, and chords. We're almost finished. So for our first one, I'm thinking this needs to be an A down here. We're looking for arc AB. That's going to be 90 because its central angle is 90. Arc CD is going to be this arc out here. Well, the angle down here is 135 because we subtract 45 from 180, also 135. Arc AC is going to be 90 and 45, which is 135. And ADC will be everything but the 135. So 135 from 360 is 225. Okay, number 5, we're going to subtract 360 minus 315. And we get 45. For that arc, it goes to the central angle, also 45. On number 6, it almost looks like we don't have enough information, but we actually notice it goes to the center this time. So that means this angle here is 125. So the x value is the supplement to the 125, so that would be 55 degrees. And then on number 7, it looks like, it's not labeled, but we have x and 70. Looks like we're going to have 20 degrees there because those are going to combine to be 90. For number 8, 9, and 10, we're thinking about a clock. So let's kind of move over here to make some room. And if I had a clock, it has 12 hours. So 12 hours to go 360 degrees. Each hour would be 30 degrees. So if I'm looking at 10 o'clock, I have one hand at the 12, one hand at the 10. If that's the case, it's 30 and 30. I have 60 degrees. If I looked at 7 o'clock, well, I can do 5 hours, or 5 times 30, which is 150. Or we could have also taken 180 and just subtracted away 30, because if it was 6 o'clock, it would be half the circle. So 30 from 180 is also 150. So the last part we get is, when is the angle 30 degrees? So for it to be 30 degrees, and we're thinking on the hour, we could move it around, but we want on the hour, we could go in either direction, so it could either be 11 or 1 o'clock. Now, next set, 11 through 16, we have CD as a diameter. So if we start matching up some values, EB, we're looking for a length. It's going to have the same length as AE, so that's 12. OB is the radius. So what we notice here actually is we have a special right triangle. So this is 12. Then we get OE is going to be 12 divided by root 3. Simplify that. So it comes out to be 4 root 3, which we double and get the radius to be 8 root 3. Now, if that's 8 root 3, when we get to DE down on 16, it's going to be 8 root 3 minus 4 root 3. So that's actually going to be 4 root 3 because it does, E is midway between O and D. Now let's look at some arcs. DB. Well, if we had that 30, 60, 90, this angle's 60, so DB would be 60, which means AD is 60, which means AC is 120, and then AB would be 60 and 60, 120. Okay, on 17 we want to find what ED is. Now just by the context of the problem we can guess it's either going to be 8 or 9. We need to figure out what chord it's the same as by looking at arcs. Now notice A to B is 25 and 55 or 80 degrees. C to D is 85. So let's find out what ED is. So we're going to do 135 plus 55 plus 25 plus 60 gives me 275, which I subtract from 360 and I get 85, which was the same as CD. So that means these two chords are the same, so ED is the same as CD. It is 9. For HI, we need to figure out what its length is. Same idea here. We're going to figure out what its arc measure is, and whatever one it matches with, we're going to say it's equal to that value. So 91 plus 78 plus 113 gives me 282. So that's all of that is 282. I subtract that from 360 and I get 78. 78 is the same as GH, so we'd say HI is also 9 units. Number 19, we want to find WY. In order to do that, we're first going to find XY here by using Pythagorean theorem. 13 squared equals 5 squared plus XY squared. We get 169 equals 25 plus XY squared. Gives me 144 equals XY squared. So XY turns out to be 12, but we want double that, so we'd say it's 24 for WY. Number 20, we want to find CD, and since the chords are the same distance away, they're both 8 units away, we can use this one, which is 14, double the 7, to find that CD is also 14.